Today we are starting vectors, okay? This is how the three-dimensional Cartesian space is divided. எத்தனை divisions வரும்? 8 division வரும். Okay? Two-dimensional plane ல 4 division, இதில் 8 division வரும். இதில் we call each of the divisions as octants. The point here is which is the first octant and how do we count it? Okay? So இப்போ இந்த இடத்துல OXYZ, okay, OXYZ, or you can just take it like XYZ, okay. So என்ன ஆர்டரில் வேணாலும் எடுத்துக்கோங்க. ஸோ நான் இந்த மாதிரி எடுத்துக்கிறேன். XOY ஃபஸ்ட்டு வந்து இந்த பிளேன் எடுத்துக்கிறேன், அதுக்கப்புறம் the projection which is perpendicular to the plane எடுத்துக்கிறேன். So XOYZ, okay, this represents the first octant. Okay, this represents the first octant. Now XOYZ on the first octant abdina, which will be the second one. So you go in the anti-clockwise direction, okay, anti-clockwise direction. So anti-clockwise direction la poringa abdina, the second one will be XOYZ, okay, second octant. Okay, so this is done. Now the third octant, okay, anti-clockwise direction, okay, just rotate, like you go like this, okay, go like this. Y dash illana X dash O Y dash Z, okay, X dash O Y dash Z, third octant. Okay, அடுத்து XOY dash Z, fourth octant. Okay, ஸோ இப்போ நீங்கள் ஃபிஃப்த் ஆக்டன்ட் பார்க்கும்போது எப்படி பார்ப்பீங்க அப்படின்னா கீழே பார்ப்பீங்க, ஃபஸ்ட்டுக்கு கீழே பார்ப்பீங்க, ஃபஸ்ட் ஆக்டன்ட்டுக்கு கீழே. ஓகே, ஃபஸ்ட் ஆக்டன்ட்டுக்கு கீழே இருக்கிறது வந்து ஃபிஃப்த்து, அதே மாதிரி செகண்ட் ஆக்டன்ட் கீழே இருக்கிறது சிக்ஸ்த்து, தேர்ட் ஆக்டன்ட் கீழே இருக்கிறது செவன்த்து, ஃபோர்த்துக்கு கீழே இருக்கிறது எயித்து. ஓகே, ஸோ ஃபஸ்ட்டு, ஸோ திஸ் இஸ் ஹவு த, இப்போ மேலேருந்து பார்க்குறோம் அப்படின்னா ஆக்டன்ட் எப்படி இருக்குன்னா இது ஃபஸ்ட்டு, செகண்டு, தேர்டு, ஃபோர்த்து. ஓகே, ஃப்ரண்ட் வியூ இல்லை, சாரி, டாப் வியூ. ஓகே, ஃப்ரம் த டாப் இஃப் யூ சி, this is how it looks like. இப்போ இந்த ஃபஸ்ட்டுக்கு கீழே வந்துட்டு, ஃபஸ்ட்டுக்கு கீழே வந்து ஃபிஃப்த்து, சிக்ஸ்த்து, செவன்த், எயித். ஃபஸ்ட்டு கீழே ஃபிஃப்த்து, செகண்டு கீழே சிக்ஸ்த்து, தேர்டு கீழே செவன்த்து, ஃபோர்த்து கீழே எயித்து, அந்த மாதிரி. ஓகே, அகெயின் த ஆன்டி கிளாக்வைஸ் 5 6 7 8 ஆன்டி கிளாக்வைஸ், சேம் as how did you do for 1 2 3 4. ஓகே, so now this is one thing. So you can make a note of it. So you don't have to specify these planes, rather you just specify the axis alone. Okay, and the x dash y dash z dash x y z and the axis மட்டும் வரைஞ்சிக்கோங்க. Okay, you can also specify the sign of each of the coordinates as well. Okay, so in the first octant it is going to be all plus, right? In the second octant, since x dash is involved, yz is positive, it's going to take only positive value, x dash is going to take negative. Okay, so negative, positive, positive. Okay, அதே மாதிரி இங்கே negative, negative, positive and positive, negative, positive. Okay, so while you are writing the octants, you can make use of this. Okay, like you start with x, y, then z. Okay. So since we are talking about vectors, the first thing, so everyone knows what is a vector, right? Something which is having a magnitude and a direction without any specification of the Cartesian space or any type of space. In a just a two-dimensional or paper la paatho appadina, you can just draw a line, and that line will have a specific direction. If it is a line segment, it will have a specific magnitude also, and you can call that line segment as a vector. Okay, subject to some context. Okay, so it can be a say for example you are drawing a free body diagram. Okay, we don't draw a free body diagram using a Cartesian space, right? It is always in a white paper we do. Okay, so in the same notion, with the same notion, here we are just introducing something like a Cartesian space. And the Cartesian space la neenga vector eppadi paakalandradha we are going to be looking at, okay, throughout the chapter. So what are all the operations we can do with respect to the three-dimensional or a two-dimensional space. Now the position vector of the point P. So the position vector of a point P is represented by a vector like this. Okay, so this is a line segment. Basically it is a line segment which is getting inclined with x, y and z axis. Okay, it is going to be having some angle of inclination with x, y and z axis. Okay, so in that case we can say this line segment is having a direction as well. It has a magnitude also. So the position vector of any point in the Cartesian plane, it is going to be with respect to the origin only. Okay, it is going to be respect to the origin only. So here the position vector of point P is P is going to be having the coordinates x, y, z. The position vector is going to be written as OP vector. Okay, OP vector, this is going to be equal to xi cap plus yj cap plus zk cap. Okay, so here the I cap, what is that I cap? I cap is the unit vector. I cap is the unit vector, and the I cap magnitude pathona 1. Okay, so here the I cap is a unit vector which is going to be along the x axis. Okay, I cap is a unit vector which is along the x axis. Adhe madri j cap along the y axis, unit vector along the y axis. K cap unit vector along the z axis. So I cap, j cap, k cap, so these are the building blocks. Basically you are just going to build any vector in the Cartesian space using these I cap, j cap, k cap unit vector components. Okay, so basically this is like showing direction to something, right? Say for example you are going to start from the origin. Okay, you are given a direction like this, you go in this way, you go in the direction of I cap. Okay, first you will be going in the direction of I cap. Okay, so you will be coming over here. Okay, so how many times that should be happening? Like say for example 3 times I cap. Okay, 3 times I cap. 3 times I cap na enna artham? நான் வந்து 3 யூனிட்ஸ் வந்து மூவ் பண்ணியிருக்கேன். எந்த பக்கம் மூவ் பண்ணியிருக்கேன்? எக்ஸ் ஆக்சிஸ் வழியாக மூவ் பண்ணியிருக்கேன். ஓகே, இப்போ நான் இந்த பொசிஷனில் நிற்கிறேன். இப்போ எனக்கு அடுத்த கமாண்ட் என்ன கமாண்ட் வரும்? I have to go like 5 units in the direction of y axis. So in that case 5 times of j cap. ஓகே, ஸோ இந்த இடத்துல நான் நிற்கும்போது எனக்கு வந்து ஒரு கமாண்ட் சொல்கிறாங்க. என்ன சொல்கிறாங்க அப்படின்னா you go 5 units in the direction of y axis. ஓகே, அப்போனா நான் என்ன செய்வேன்? எக்ஸ் 3i cap போயாச்சு, 3i cap முடிஞ்சிச்சு, ப்ளஸ் 5j cap. ஓகே, 3i cap plus 5j cap. அடுத்து I just have to travel. So now I am over here. So now I just have to travel vertically. I just have to travel in the direction of z axis. Okay, to how many units? 7 units. So in that case plus 7 k cap. Okay, so what is my final position? This is my final position. Okay, so now we can understand that this position can be represented with respect to the origin as a vector which we give as xi cap plus yj cap plus zk cap. Okay, this is how it goes. இப்போ இது வந்து with respect to origin நம்ம define பண்ணியாச்சு. இப்போ with respect to origin நான் define பண்ணும்போது with respect to any point I can define, right? With respect to, if I can represent a position of a point with respect to origin, I can represent the position of the same point with respect to any point in the Cartesian plane other than the origin, Cartesian space. So for example we take a point Q over here. Okay, we take a point Q. Now we have a vector which represents the position of the Q point. I will just name this as OQ vector. Okay, so we will just write what is OQ vector. Let me take the coordinates as x1, y1, z1. Okay, இப்போ இங்க x1 I cap plus y1 j cap plus z1 k cap. Okay, now I am asked to find what is PQ vector. What is PQ vector? So PQ vector, in the sense I am saying that I am representing that PQ vector in this way. Okay, it's like OP minus OQ is PQ. Okay, so how do you measure it? PQ vector is going to be final minus the initial point. Okay, so what do we have here? Okay, but it is always like final minus the initial. That's how we do. But this is my final point, right? Oh, okay. Yes, yes. Yes, yes, yes. Yes, yes. That is the correct one. Yes. So QP vector. So QP vector is going to be like, so my initial point is Q, final point is P. The way I have represented it is wrong. Okay, PQ is not the representation. QP. Okay, so final minus initial. So here OP minus OQ gives me PQ. Okay, so this is how we define. So here also we do the same thing. OP vector, O was the initial point, P was the final point. Okay, yes. So in the convention வந்துட்டு மைண்ட்ல வச்சுக்கோங்க. This is a very important convention. So whenever we represent a vector which is joining two different points, we write it as QP vector. QP in the sense P is the final point, Q is the initial point, and QP vector is going to be measured like OP minus OQ. Okay, so now we have the OP vector. So basically what is the x? It is the reflection of the vector on the x-axis. Okay, it is the reflection of the vector on the x-axis. Okay, basically we call it projection. Okay, Again we have the projection of this vector on the z axis, projection of OP vector on the y axis. Okay. Now we just make a perpendicular. So here they have given you a configuration in a two-dimensional way. Okay, this is going to be a plane which is actually facing the other side. Okay, so they are just giving you a view of this one in the board. Okay, when you are going to look at in this way, you can just see it in a two-dimensional way. So now this x being the projection of this vector, this x is also the coordinate of the particular point for which you are finding the position vector of the point. Okay. So there is a relationship, right? There is a relationship between x and the distance from O to P, right? So basically the angle which is formed over here, okay, you just look at this point, okay, the x, O and this y, okay, and this r vector, okay, A, O and this point P, okay, AOP. Look at this portion alone. So what is the angle being formed here? Is it really obtuse? Is it obtuse? It just looks like obtuse, right? It is looking like obtuse. It's not obtuse. So now, is this angle really obtuse? That's my question. AOP, whether the angle is obtuse. No, talking about this one, AOP. AOP. The angle. It is looking like obtuse. It's not actually obtuse. It is not actually obtuse. Okay. So understand this point is somewhere like this. Okay, it's just somewhere like this. Okay. So this angle is not obtuse here. பார்க்கதா அந்த மாதிரி தெரியும், நீங்கள் இமேஜின் பண்ணி பார்த்தீங்கன்னா தெரியும். Okay, so this angle is not obtuse. So basically what is the relation between x and this OP and that angle? So if I am going to name that angle as, say, I am just going to name that angle as alpha. Okay, I'll just name that as alpha. So what will be cos alpha? This is the adjacent side, this is the hypotenuse. Can you get the point? So x by OP. Okay. Similarly, this is the hypotenuse. So here you can easily see that. In the z part you can see. When the projection is on z axis, you can see that easily, right? So here the angle you can take it like gamma. So if you take it like gamma, what you can say? Z by OP. Okay. So cos gamma equal to Z by OP. Adhe madri beta, the angle formed between OP and the y axis. Okay, understand the angle formed between OP and y axis is beta. The angle formed between OP and x axis is going to be alpha, and it is looking obtuse but it is not obtuse. Okay, so cos beta is going to be equal to y by OP. Okay, so these are called as direction cosines. Okay, cos alpha, cos beta, cos gamma are called as direction cosines of a vector, and this can also be extended to any line which is having the direction vector as OP vector. Okay, that we will study in three-dimensional geometry. So these are called as direction cosines. So that's why they gave you this OAP over here basically, right? So this triangle is this triangle. Okay, So here you can see the angle is not obtuse, right? The angle is not obtuse. Okay. So for example, you are looking your point of view over here. If you are having your point of view over here, இங்க இருந்து நீங்க பாக்குறீங்க அப்படினா இப்படி தான் தெரியும். Okay. So usually we have a notations for this. So we just call this as L, this as N, this as M. Okay, L, M and N. Okay. So basically now there is another definition coming up. What about this X, Y, Z? So basically direction ratios, right? So if I take OP as or you can just leave OP as OP itself. So X is equal to OP into cos alpha, Y is equal to OP into cos beta, Z is equal to OP into cos gamma. So that means I can just write this as X is equal to, if I take OP as R, okay, just represent that as R. In that case, what can I say? Okay, since it is we are using the P alphabet, we'll just write it as small p. Okay, so P times of L, Y is P times of M and Z is P times of N. Okay, so PL, PM, PN. So these are direction ratios. Okay. So from here you can just easily see that the direction cosines are proportional to the direction ratios. Okay. Or you can simply say in another way, the coordinates of a point, if they are going to be proportional to these numbers, then that point is going to be lying on the line which is coincident with this vector. Okay, அப்படியே சொல்லு. The point is, if you find any point which is proportional to these numbers, okay, then you can say that point is going on a line which is coincident to this vector. Basically the line which is passing through this vector will also pass through that point as well. Okay, what else? So it is like you have seen this somewhere but you are not able to, you can understand, right, the connection between these things L, M, N and the coordinates of a point. So basically if you know the two-dimensional space, two-dimensional vectors, you can understand this also very well. Okay, just one axis is extra, that's all. Okay. So basically in the two-dimensional also you have LM, we don't have N. Okay, but we don't use the words LM, direction cosines in the two-dimensional space. Instead we use sin alpha, cos alpha. When we talk about a x component, we talk about cos alpha. Resolution பண்ணோம் அப்படினா நான் எப்படி resolution பண்ணுவேன், r cos alpha, r sin alpha பண்ணுவோம். Okay, but இங்க sin க்கு வந்துட்டு we are not using sin anywhere here. We are just representing everything in terms of cos here.